Hey guys, today we are going to be doing Unit 3, Lesson 4, which is a continuation of what we've been doing. I do want you to remember how to reference the reference sheet, which is posted into Canvas, okay? It is under Unit 3, right in front of Lesson 3. So be sure that you use that reference every single time that we're doing triangle congruencies and proofs, all right? Let's go ahead and jump in today. We're going to do angle, side, angle, 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 side, and also hypotenuse leg at the end, okay? So what this theorem or congruency statement is that if two angles, and the included side, remember included side means that the side is in between the angles, okay, are congruent, and the included side of one triangle are congruent to two angles and an included side of the other triangle, then the triangles are congruent. So this is pink angle, blue angle, included yellow side. Okay, and so I've marked them. Pink angle, blue angle, included yellow side. So angle, side, angle. If you can say those three things, then you can say that the all parts of this triangle are congruent to all parts of this triangle. Okay. Included means the side between the angles. All right, let's go ahead and jump in and take a look at our proofs for today. Okay. Make sure I'm zoomed in good. Okay. So SQ bisects RQT and RST. So this is our given information. Given. Okay. And so what does that mean? Well, let's take a look here. This tells me next that angle RQS right here, is congruent to TQS. And I can say that because that is the definition of what it means to be a bisector. Okay, so definition of bisector. Next, it tells me angle RSQ is congruent to TSQ. So how do I know that these two angles are congruent? Again, that is the definition of bisector. So when you have a figure that cuts with this line that's a bisector and it cuts through two angles, it bisects both of those angles on both sides into two equal parts. Okay? Next, QS is congruent to QS, and that's the side here. How can I say that that is true? That is the reflexive property. That side is congruent to itself. And so let's take a look at what I've got here. I've got an angle, a side, and another angle. Okay, so I can say that's true by angle, side, angle theorem. Angle, side, angle. Let's take a look at example 2. Okay, JM, and again, remember what this means is parallel. Okay, so JK is parallel to LM. Okay, so I know that because it's given. They also tell me JL is parallel to KM. Okay, so they gave me two pair of parallel lines. That was all given. Now let's think about how we could figure out some of these angle congruencies, okay? Angle JKL, let's mark it, is going to be congruent to MLK. And how do I know that these are congruent? Well, they're in between two parallel sides, and they're on opposite sides of this bisector. Okay, so these are going to be alternate interior angles. Okay, so let me pull up my reference sheet. I just really want to remind you that on this reference sheet, there are three that were in green right here. The ones that are in green, you must have parallel lines in order to use these, okay? So once I have parallel lines, then I can start to pay attention to these three, okay, congruency statements. All right, next they tell me that JLK, this is going to be a second angle congruency statement, so I'm going to use two tallies, is congruent to MKL down here. Okay, and how can I say that those are congruent? Well, they are also on the insides of some parallel lines, and they are on opposite sides of what would be the transversal. So again, I have alternate interior angles. So if I'm going to shorthand alternate interior angles, those mean the same thing. Okay. All right. Next, I have KL is congruent to LK. That's this side in the middle. And I know that this is true because of the reflexive property. Remember, every side is always going to be congruent to itself. So here's what I have now. I have an angle, a side, and an angle. And in the other triangle, I have, here's the first angle, the side, and the second angle. Okay, so I have angle, side, angle. Excellent. All right, let's go look at example 3. Example 3, we are going to be responsible for filling in our own statements. Okay, so let's go ahead and fill in our first two statements. Angle BAC is congruent, so BAC is congruent to DEC. And I know that because that was given information. So be sure that you label your given information. All right, next they tell me that C is the midpoint of AE. Okay, so if that is the midpoint of AE, let's go ahead and identify AE. All right, so there's AE. C is the midpoint. So what can I say next? What can I say next? Well, I could say that this side of this line is congruent to this side of the line because the midpoint cuts this line into two equal side lengths. Okay, Oh, I forgot to write this was given. So what I'm using right now is the definition of midpoint. Okay. So by the definition of midpoint, I can say that AC is congruent to CE. All right. All right, next, can I figure out any other information just by looking at this? Okay, well, I know something about these two angles. I know something about them. I know that they're going to be congruent, but how are they going to be congruent? So let's say ACB is going to be congruent to ECB. They are going to be congruent because they're vertical angles. Okay, vertical angles. And so the very last statement in a proof is what it is that you're trying to prove. So triangle ABC is congruent to triangle EDC. And how do I know this? I have an angle, an included side, and another angle in both of these triangles. So I have angle, side, angle. Excellent job. Let's look at our last side that requires 3 pieces of information. I have angle, angle, side. Okay, so if two angles and a non-included side. Non-included means a side opposite one of the angles, okay? In one triangle that are congruent to two angles and a non-included side in a second triangle, then the triangles are congruent. And here's how this looks if I write it out mathematically. Okay, angle A is congruent to angle D. Angle B is congruent to angle E. Side BC is congruent to side EF. So therefore, these two triangles must be congruent. All right. And so just let's be aware of what non-included means. Non-included. And I really should go back here and highlight included means the side between the angles. Okay. Alrighty, so that was the angle, side, angle. Okay, so we are going to start looking at some proofs with angle, angle, side. All right, we're going to fill this out entirely on our own. So let's go ahead and do this. YZ, this line right here, bisects angle WYX. Okay, so YZ bisects angle WYX. Okay, so that's a bisector and that's given information. Okay. All right, next, you could if you want to. So again, if you're filling in the reasons, you can do this any way that you see it. Okay. I could say from the definition of bisector that this angle WYZ is going to be congruent to angle XYZ. Okay, these two angles are going to be congruent by the definition of what this bisector means. All right, next they tell me that YWZ, this angle, is congruent, so let me mark it, is congruent to YXC. Okay, so I'm going to write this down. YWZ is congruent to YXZ. Okay, and I know this because it was given to me. It was given to me. Okay, there's one more piece of information that I can decide just by looking at this, and that is that YZ is congruent to itself. Okay, this side right here. And that is because of the reflexive property. Alrighty, so now I'm at the very last statement where I can indeed say that these triangles WYZ and XYZ are congruent by angle, angle, side. Angle, angle, side. Okay, that's our very first proof of angle, angle, side. Okay, let's take a look at another example. Here we go. All right, so we're trying to prove that triangle ABC is congruent to triangle CED. Alrighty, let's start with what they tell us. Angle ABC right here is congruent to angle CED right here. I know this because they gave it to me. Alrighty. What else can I say? AB is parallel, remember, parallel to CE. So AB is parallel to CE. Okay. Alrighty. Now what? I lost myself. I don't know where I am in my notes. Okay. Let's see. So that was given. And then I can also say what is given is that C is the midpoint. C is the midpoint of AD. And that is also given. Okay, so if C is the midpoint of this segment, then that means midpoint, I always like to label things, then that means that this side of C is congruent to this side of C. So AC is congruent to CD. And that is by the definition of midpoint. Okay. All right. Now what do I know? So I see that I've got parallel lines here, guys. So I need to start looking for alternate interior, alternate exterior, or corresponding angles, okay? So if I were to extend these just a little bit to make their parallel lines look, okay, so I've got these two parallel lines and they're being cut by this yellow transversal, okay? What can I say? Well, I can only say something about something on this side and on this side. Well, this and this and this are all outside of the triangle, okay? They're on the outside of the triangle, so they're not going to be included in this proof anywhere. The only side or part of this that I can really think about is what's inside the triangle. So that side is going to mean something. Angle CAB, angle CAB. It has to relate to something else in this figure. Okay, so again, this is the transversal. These are the two parallel lines. Notice that this angle and this angle are on the same side of the transversal and on the same side of each parallel line. So these two angles, CAB and DCE, are congruent by the by corresponding angles. Corresponding angles. Okay. And I spelled that wrong. There should be two R's here. Corresponding angles. All right, so let's take a look at what we have now. We're trying to prove triangle ABC is congruent to this triangle. Okay, so I have a side, an angle, and an angle. A side, the yellow side, an angle, and an angle. So side, angle, angle might be how you see it, but remember that the proper way to say the theorem is actually angle, angle, side. Angle, angle, side. Okay? So be careful that you don't write it as this. Angle, angle, side. All right. Two more examples and then we're done with today's lesson. Okay. All right. So PR bisects. PR bisects angle QRS. So PR is a bisector. QRS. Okay. So I know that because it was given to me. And now let's think about what is an angle bisector. An angle bisector cuts this big angle into two equal parts, okay? So I can say SQR, QRS, I wrote it on the wrong side, guys, sorry. It bisects this angle down here. All right, so I'm going to leave this here just for a second. So QRP is going to be congruent to SRP. or I could say PRS, either way. So angle PRS is going to be congruent to angle PRQ. Okay, that is by the definition of an angle bisector. Okay, then they tell me angle PSR, okay, is congruent to PQR right here and right here. And so I know that information because it was given to me. So angle PQR. All right, well, the very last part of my statement side is going to be that PSR is congruent to PQR. So I need to know one more piece of information to get myself there. Okay, remember, this was a mistake. All right, so I've got this line PR. Can I say that PR is congruent to itself? I can. Okay. PR is congruent to PR. And the property that I use is the reflexive property. Okay, it's congruent to itself. And so what I have now is I have an angle, and a non-included side. An angle, and a non-included side. All right? Angle, non-included side. Okay, we have one more like this, and then we're going to do the hypotenuse leg. So again, I'm seeing some stuff with parallel lines, parallel. So LG, let's find LG. Here it is parallel to JM. LG parallel to JM. So I've gone ahead and marked my parallel lines. Alrighty. So if these are parallel lines, and that's given, I'm going to say that angle LGH is going to be congruent to angle MLH. So how do you know that these two angles are congruent? Okay, because we have parallel lines, I want you to think about the theorems that we have available to us. These are alternate interior angles. Okay. Because of the parallel lines, that's why I can say this, okay? Next, I can also say that this angle and this angle are congruent. So let's see, I have JHM. JHM is going to be congruent to GHL. GHL. And I know that because these are vertical angles. Vertical angles. Alrighty. What else can I say? I can say that Oh, H is the midpoint. H is the midpoint, so let me add that. H is the midpoint of LM. So I know that because they gave it to me up here. This was given information. Remember, when you're filling in your own statements and your own reasons, you can do this in any order that you see it. Any order that you see it. Okay, so LM, H is the midpoint of that. Let me highlight this line. LM. So what I can say is that HM is congruent to HL. And how can I say that? That is by the definition of midpoint. Okay? All right, so I've gotten all the way here. I have an angle, and a non-included side. Again, I have an angle, and a non-included side in the other triangle. So I can say angle, side. I've just proven these two triangles are congruent, okay? Which is what I was supposed to prove. That's always my last statement. Now, even though you are currently filling in your own statements and your own reasons, because they're numbered, you kind of have an idea of when you have found all the information that you need. So it's still somewhat guiding you, okay? Still somewhat guiding you. Okay, I know that this gets a little hard, guys, when you start putting all of these together, okay? But we have one more to do, and then I'm going to go ahead and put up our review cheat sheet, okay? So hypotenuse leg, that is our HL. These have to do with right triangles only, okay? So if the hypotenuse and a leg of one triangle is congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So my hypotenuse and my leg, and I know that they've got both have at least this one right angle. Okay, so let's jump right in and take a look at a proof. And just recall, okay, that the hypotenuse is the side opposite the right angle, and the leg is one of the two sides adjacent to the right angle, meaning it's beside it. So it's either got to be this side, or it could have been this side down here, AC as well, okay? So we're just going to look at two proofs that have to do with hypotenuse leg, and these are going to be pretty simple. All right, so they're giving me these statements. Triangle, LMP, okay, and MNP are right triangles. That's given information right here. Okay, and they've already labeled the right angle for me. They also tell me that ML, let's find it right here, is congruent to MN. That's also given. Okay, so that's the hypotenuse. That's the side opposite the 90-degree angle in both triangles. So now we need to prove that these triangles are congruent. Well, my statement says MP is congruent to MP. This is MP right here. How do I know that MP is congruent to itself? And that is the reflexive property. Okay, And so finally, I have proved that these two triangles are congruent by hypotenuse leg. I have a hypotenuse and I have a leg. Hypotenuse, hypotenuse, and then the leg I had in pink. And that's it. That's all there is to it. So whenever you have a right triangle, you pretty much know that it's going to end up being hypotenuse leg, more than likely, okay? A second example, and then we're done with examples. Let's start with what they give us. Triangle WVX, and triangle YZX are right triangles. So, okay. So these are right triangles. Okay. I ran out of space, so I'm going to put a triangle with a comma S for it. So this is given to me. Okay. WVX and YZX are right angles. Okay. Or right triangles. Now they tell me that WV is congruent to YZ. So let's mark these. WV and YZ right here. These are congruent to one another. That's also given. And then last, it tells me that X is the midpoint of WY. I always like to color my line that they're talking about. So WY. And X is the midpoint. Okay, so if X is the midpoint, then that means that this side and this side are congruent to one another. Okay, so WX is congruent to YX, and that is by the definition of midpoint. And I forgot to fill in this was given. Okay, so now I have filled in all the information I can. I have a hypotenuse, I have a leg, I have a right triangle. Okay, so I could say that I have hypotenuse leg. Hypotenuse leg. So WVX is congruent to YZX. All right. Some of you might have looked at this and you really, really wanted to say that these two angles are congruent by vertical angle theorem, and you would have been correct, okay? And then these two angles are congruent because by the definition of right triangles, and so you could have said by the triangle sum theorem that this angle is congruent to that angle. And you could have solved this using angle, 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 or tried to. However, angle, angle, angle doesn't prove that the side lengths are congruent. So we still needed to know about some of these sides, but you could have done side, angle, side. Okay. There's lots of different ways that we could have gone about proving these two triangles congruent based on the figure or the information that they've given us. Okay. So don't forget about that triangle sum theorem as well. You can also use that if you need to. But the more practice that you get writing proofs, 2-column proofs, you're going to learn that the more various ways you can start to prove things, the more you learn, the more you can prove. Okay, so let's go back. This is the end of this. This is our second lesson on triangle congruency specific theorems. And these are the 5 theorems that we've just learned in our last 2 lessons. Okay, so again, we have side, 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 angle, side, angle, side, angle, 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 side, and I hypotenuse the leg. There is no angle, angle, angle. There is no angle, side, side. Okay. All right. And then the reasons down here. Again, these are not the only possible reasons, but these are really common ones. Okay. Again, I just mentioned you could have also used the triangle sum theorem for one of the last problem that we did. Okay, if you can prove 2 of the sides of 2 or 2 of the angles of 2 triangles are congruent, then you could also prove that third side by using the triangle sum theorem. Okay, so again, refer to this cheat sheet or this reference sheet. You want to have this out every single time that you're taking a quiz, a test, or doing practice assignments, okay, that have to do with these, until you learn them anyway. So you're not being required to memorize them. I am giving you this sheet to reference them, okay, so that you don't have to memorize it all. Alrighty, but this was lesson 3. This was lesson 4. Let me just go ahead and add that here. So, lesson 3, lesson 4. And your teacher may have chosen to break this down into a 5th lesson. Okay? For our class tomorrow, we will be practicing. So instead of having a 5th lesson, because I did it all at once, we will be practicing all of these triangle congruencies. Okay? All right, guys. Until next time.